You settle in, and for a moment, you imagine that inside your head there is not a machine, not a rigid clockwork of parts, but a landscape. A living map. Soft hills and winding paths made not of earth, but of cells and signals. This landscape is your brain, and it is never still. Even now, as you rest and listen, it shifts in small, graceful ways. You may have once been told that the brain is fixed early in life, like concrete poured and hardened. But the quieter truth, the more comforting truth, is different. Your brain is more like clay kept gently warm. It can be shaped and reshaped. Not instantly, not forcefully, but gradually, through use and attention and repetition. Each thought you think is like a footstep on a trail. When a thought repeats, the trail becomes clearer. When an action repeats, the grass along that path bends more easily next time. This is one of the core principles of brain science, though you do not need the technical words to feel it. Cells that activate together begin to coordinate more smoothly. Signals travel with less resistance. The path becomes preferred. You can picture billions of tiny trees made of light, each one a neuron, branching and reaching. They do not touch, but they come very close, with tiny gaps between them. Across those gaps, chemistry and electricity pass in delicate pulses. This crossing point is like a narrow bridge over a stream. When it is used often, it grows stronger and more efficient. When it isn't used, it slowly fades back into quiet. Nothing is wasted. Nothing is punished. The brain is economical in kind. It invests where you visit. You are not separate from this map. You are both the traveler and the terrain. When you practice a skill, when you revisit an idea, when you feel an emotion deeply, you are marking the landscape. Modern measurement tools allow scientists to observe this change, new branches forming, connection points enlarging, insulation thickening around frequently used signal routes. The structure itself responds to experience. This capacity is called neuroplasticity, but you can simply think of it as adaptability made visible. Consider how a child learns a new sound, a new word, a new movement. At first it is effortful, uneven, then smoother, then natural. The change you witness in behavior is supported by physical change in tissue. The map redraws itself to make the journey easier next time. And this does not end in childhood. Even now, across your lifespan, your neural landscape remains responsive. The pace shifts with age, yes. The speed of construction may slow, but the door does not close. New routes can still be formed. Old ones can still be strengthened. Detours can still be learned. The brain prefers efficiency, but it never refuses renewal. You might like to imagine your day as a series of glowing threads. Attention is the light that brightens certain threads more than others. Whatever you attend to repeatedly becomes easier to find again. Attention is like moonlight on a path. It does not create the path by itself, but it makes walking it more likely. Emotion adds another layer. When you feel something strongly, your brain releases chemicals that act like gentle fertilizer on active pathways. This is why emotionally meaningful moments are remembered more easily. The pathways formed during feeling are nourished more deeply. The map marks them as important. This is not something you must control tightly. In fact, the brain changes best in conditions of steady, relaxed engagement. Pressure and fear narrow the landscape. curiosity and safety widen it. When you explore with interest rather than force, more of the terrain becomes available for change. Right now, even listening, you are shaping pathways. Language flows in, images form, associations awaken. Networks coordinate to interpret tone, rhythm, meaning. Your auditory regions converse with memory regions. Your emotional centers add color. Your attention networks hold the thread. A quiet orchestra performs without applause. You do not feel most of this activity directly. It happens below awareness, like roots growing under soil at night. But its effects appear in what becomes easier tomorrow, and easier still the day after. There is also a gentle pruning that happens in this living map. Connections that are rarely used grow thinner. Some withdraw entirely. This is not loss in a tragic sense. It is refinement. Like a gardener trimming excess branches so sunlight can reach what matters most. Efficiency is a form of care. You are not required to keep every path active. Forgetting is not failure. It is space-making. The brain balances growth and pruning continuously. Build and simplify. Strengthen and release. This balance keeps the network flexible rather than tangled. Too much rigidity would trap you. Too much randomness would confuse you. Plasticity is the middle way, structured, but responsive. Imagine now that each habit you repeat is like walking a circle in soft sand. The circle deepens. The next step falls into the previous step's curve. Habits feel automatic not because they are magical, but because the neural path has been gently carved through repetition. Energy flows where resistance is lowest. This is why small changes matter. A tiny new behavior, repeated calmly, can begin a new curve in the sand. At first it feels unfamiliar. Then less so. Then natural. The map updates quietly, without announcement. Your brain is not judging the direction of the path. It is simply observing frequency and intensity. It asks only, is this visited often? Is this marked as meaningful? If yes, it allocates resources. If not, it conserves them elsewhere. There is comfort in this neutrality. You are not fighting your brain when you learn. You are collaborating with it. Across your cortex, the folded outer layer, patterns ripple like wind across tall grass. Deeper inside, memory structures coordinate with emotional centers and timing systems. Chemical messengers adjust the likelihood that one neuron will listen to another. Support cells regulate energy and cleanup. Blood vessels widen where demand increases. The map is biological, yes, but also lyrical in its choreography. And here is the gentle wonder, no two maps are identical. Even identical twins, sharing genes, develop distinct neural landscapes through different experiences. Your map is uniquely walked. Your paths are personally worn. As you rest, you might sense this inner territory with appreciation. Not as something fragile, but as something alive and responsive. Not fixed, but faithful. It changes with you because it is you. You do not need to force transformation tonight. Simply noticing is enough. Awareness itself is a kind of visitation, and visitation is the beginning of change. And as you continue to wander this inner landscape, You may begin to wonder how the tiny lights, the individual cells, speak to one another across their narrow bridges, and what quiet language passes between them in the dark. You move closer now, gently, as if leaning in to hear a soft conversation behind a door. Inside your living mental landscape, beyond the hills and pathways, there are countless tiny messengers at work. They do not speak in words. They do not raise their voices. Yet their dialogue never stops. Your brain is made of billions of neurons, each one like a small branching tree made of living thread. Every neuron reaches outward with delicate arms, dividing and dividing again, as if searching for neighbors in the dim light. They rarely touch directly. Instead, they leave a narrow gap between one another, a space so small it could fit thousands across a human hair. This tiny space is where the conversation happens. You can imagine it like two cliffs facing each other across a narrow canyon. When a signal travels down one neuron, it reaches the edge and must cross. It cannot jump as a solid object. Instead, it transforms. Electricity becomes chemistry. A small packet of messenger molecules is released, drifting across the gap like pollen on still air. On the other side, receptors wait like open hands. If the shape matches, the message is received, and a new electrical ripple begins. This crossing place is called a synapse, but you can think of it as a whispering bridge. Each time a signal crosses successfully, the bridge becomes slightly easier to cross again. Not dramatically. Not all at once. But gradually. The receiving side becomes more responsive. The sending side becomes more reliable. Support structures adjust. Proteins rearrange. Microscopic scaffolding strengthens. The crossing grows smoother. This is how repetition becomes memory in physical form. You do not feel these crossings directly. There is no sensation when a single synapse grows more efficient. But multiplied across millions of connections, the effect becomes your learning, your habits, your familiar reactions. The brain is not storing thoughts like books on shelves. It is tuning conversations between cells. Some conversations are brief, a passing comment between strangers. Others become long friendships, stable, quick, dependable. When two neurons are active at the same time again and again, their connection tends to strengthen. Scientists sometimes summarize this with a simple phrase: cells that fire together, wire together. You can picture two lantern bearers who often meet at dusk. Eventually, they begin waiting for each other. Timing matters here. When signals arrive in close rhythm, the bridge reinforces. When they rarely coincide, the structure relaxes. This gives your brain a beautiful sensitivity to pattern. It is not just activity that matters, but coordinated activity. Harmony builds structure. There are also gentle braking systems in place. Not every signal should pass through with equal force. Some synapses are designed to soften or quiet activity. These are like moss along a path, absorbing excess sound. Without them, the system would become too loud, too unstable. Balance between excitation and inhibition keeps your mental weather calm enough for clarity. Chemical messengers vary in their effect. Some increase the likelihood that the next neuron will speak. Others decrease it. Some adjust mood across wide regions. Others fine-tune a single crossing. You might imagine different kinds of ink used to write messages, some bold, some faint, some lingering longer on the page. Energy is required for every whisper. Your brain, though only a small portion of your body weight, uses a large share of your available fuel. Glucose and oxygen arrive through branching blood vessels, delivered precisely where activity increases. The more a region speaks, the more nourishment it receives. Supply follows conversation. There are helper cells too, surrounding neurons like careful attendants. They regulate the chemical environment, recycle used messengers, and provide metabolic support. For a long time they were thought to be passive. Now we understand they participate actively, adjusting the conditions of communication. Even the background is alive. When you practice something, a melody, a phrase, a movement, certain neural conversations repeat in similar patterns. At first the dialogue is hesitant. Signals misfire. Timing wobbles. With repetition, the pauses shorten. Reliability grows. Layers of insulation around frequently used neural fibers can thicken, allowing electrical signals to travel faster and with less loss. The message arrives clearer, like a well-tuned instrument. Unused conversations fade gently. Receptors reduce in number. Release becomes less likely. The bridge narrows. Again, this is not punishment. It is efficiency. Silence is also part of healthy communication. By letting quieter paths rest, the brain frees resources for the messages that matter most in your daily life. Emotion can raise the volume of certain exchanges. When you feel surprise, fear, joy, or deep interest, neuromodulators flow more widely, adjusting how strongly synapses change. It is like switching the brain into highlighter mode. Important moments are marked with brighter ink. This is why emotionally charged learning often lasts longer. Attention works similarly. When you focus steadily, specific networks maintain activity long enough for strengthening to occur. Wandering attention produces lighter marks. Gentle, sustained noticing produces deeper ones. This is why slow, calm engagement is so powerful for lasting change. Right now, as you listen, networks for sound, language, imagery, and self-reflection are exchanging signals in coordinated patterns. Not rushed. Not forced. Just active enough to shape themselves slightly around this experience. Your brain is adjusting to your present moment like water settling into a new container. You might find it soothing to realize that improvement does not require intensity. Volume is not the same as effectiveness. In neural change, consistency beats force. Soft repetition outperforms sudden strain. Like drops of water shaping stone, steady signals reshape synapses. There is also variability built into these crossings. Synapses are not identical switches. They are probabilistic, meaning each signal has a likelihood, not a guarantee, of passing through. This introduces flexibility and creativity into the system. Your brain is not a rigid circuit board. It is a responsive conversation network, always slightly improvising. When many neurons coordinate their whispers, rhythms emerge, brain waves detectable from outside the skull. Slow waves, fast waves, mixed patterns, each associated with different states of awareness and rest. These rhythms are like the background music behind the dialogue, setting tempo and mood. As your body relaxes, some rhythms slow. Coordination shifts. Conversations become less externally focused and more internally integrative. The bridges keep passing their lanterns, but the scenery grows dimmer and more dreamlike. And you may begin to sense that if each connection is shaped by use, then each experience you live is not merely passing through you, it is gently rewriting how these tiny voices will speak to one another next time, and that leads you naturally to wonder how your moments, your habits, your repeated days are quietly redrawing the deeper map. You continue your quiet journey inward, and now you begin to notice something even more comforting. Your brain is not only alive and communicating, it is responsive to experience in a deeply personal way. What you live through does not simply pass by like weather. It leaves gentle structural traces. Each moment lays down a faint new layer, like soft snowfall across a field. No single snowflake changes the landscape, but accumulation does. Experience works in much the same way. A single attempt, a single exposure, a single practice round feels small. Yet your brain records patterns across time. When similar signals arrive again and again, your neural landscape adjusts to welcome them more easily. Tiny branches extend. Connection points enlarge. Signal timing improves. What was once effortful becomes more fluid. You can imagine learning as path-making after fresh snow. The first crossing is slow. You lift your feet high. You are unsure where to step. The second crossing follows roughly the same line. The third becomes clearer. After many crossings, a visible trail appears, not because the snow chose it, but because repetition shaped it. Your neurons behave with similar patience. When you practice a skill, whether mental or physical, repeated activation of certain networks triggers molecular changes inside cells. New proteins are built. Structural supports are rearranged. Gene expression shifts slightly to maintain the new pattern. This is not dramatic from moment to moment. It is incremental, like dawn brightening by degrees you barely notice. Mistakes are part of the shaping. In fact, variation improves the map. When you try, err, adjust, and try again, your brain compares outcomes. Circuits involved in prediction and feedback refine their timing. Error signals are not punishments, they are guidance lights. They help redirect the next signal wave more accurately. You might find it soothing to release the idea that learning should feel smooth from the beginning. In biology, rough drafts are expected. Refinement is built from correction. Attention plays a special role in which experiences become structure. You are constantly exposed to more information than your brain can physically encode in detail. Attention acts like a spotlight moving across a dark stage. Wherever it lingers, change is more likely to occur. Signals repeated under attention produce stronger synaptic adjustments than signals that pass unnoticed. This means your focus is not just psychological, it is architectural. When you attend gently and steadily to something, a sound, a concept, a movement, you increase the probability that related neural bridges will strengthen. It is like warming wax so an imprint holds more clearly. Divided attention leaves lighter impressions. Calm focus deepens them. Emotion adds another layer of selection. Experiences that carry feeling are tagged by your chemistry. Neuromodulators circulate and adjust how plastic, how change-ready certain circuits become. This is why meaningful experiences often teach more effectively than neutral ones. The brain quietly asks, "Does this matter?" If the answer is yes, resources gather. You do not need intense emotion for this effect. Even mild personal relevance helps. Curiosity counts. Gentle interest counts. A sense of usefulness counts. The system is responsive, not extreme. There is also timing in how experience rewrites your brain. After learning episodes, consolidation periods follow. During rest, especially sleep, recently active circuits replay patterns in compressed form. It is like your brain rehearsing softly behind closed curtains. These replays stabilize fragile changes, turning temporary traces into longer-lasting structure. So learning is not only what happens during practice. It is also what happens afterward, in quiet. Repetition spaced across time is especially powerful. When you revisit material after pauses, the brain must reactivate the pathway rather than simply continue it. This reactivation strengthens retrieval routes. It is like reopening a trail after light snowfall. Each reopening makes the path more durable against future covering. You might appreciate how forgiving this system is. Gaps do not erase progress. Returning rebuilds quickly because some structure remains. Environment also shapes rewriting. Enriched surroundings, variety, movement, social interaction, mental challenge correlate with greater branching and connectivity in many brain regions. Monotony produces less structural growth. Your nervous system expects a world with texture. Even small novelties, a new route, a new idea, a new sound, provide gentle stimulation for adaptive change. Your body participates too. Physical movement increases blood flow and releases growth-supporting factors that encourage neural health and plasticity. When you move, you are not only exercising muscles. You are signaling the brain that adaptability is required. Chemistry responds accordingly. Nutrition, hydration, and oxygen supply influence how well rewriting can occur. Cells build structure from available materials. Rest supports repair. None of this requires perfection. It simply means your daily rhythms quietly assist your neural evolution. There is a beautiful subtlety here: change competes. Neural resources are finite. When certain pathways strengthen, others may weaken from disuse. This is not loss, it is specialization. Your map becomes more efficient for the routes you travel most. This is why intentional practice matters. You are voting with repetition. Habits form through this competitive strengthening. A behavior repeated in consistent context recruits similar neural patterns each time. Context cues begin to trigger preparation signals automatically. Eventually, the loop runs with minimal conscious oversight. This saves energy. Automation is a gift when wisely chosen. And if a habit no longer serves you, the same plastic principles allow reshaping. New repetitions can build alternate routes. At first they feel awkward because the old road is wider. With time and gentle persistence, the new road becomes more inviting. The brain does not resist change, it responds to frequency. Across your lifetime, experience continues this rewriting. Even in later years, neurons can adjust connection strength, grow new spines, alter responsiveness. The pace may slow, but the pen never lifts completely from the page. Your story remains editable. Right now, as you absorb these ideas, patterns are forming associations between imagery, meaning, and calm. Circuits that link learning with safety are being gently co-activated. This pairing itself supports future openness to change. Safety is fertile ground for plasticity. You might rest with that thought that every calm, attentive moment is not idle. It is constructive. And as you sense how experience layers itself into living structure, you may begin to wonder how time itself interacts with this rewriting, whether the aging brain truly loses its flexibility, or whether something more hopeful is quietly true, waiting just beyond this understanding. You rest a little deeper now, and a familiar belief begins to loosen, the old story that the brain grows rigid with age, like wood that can no longer bend. It is a common story, repeated often, but it is not the full truth. Your brain does not turn to stone as years pass. It changes its pace, yes, but it does not surrender its ability to change. Imagine a forest through the seasons. In early spring, growth is fast and bright. Shoots appear everywhere at once. Later, growth becomes more selective, slower, more deliberate. But it does not stop. Roots continue to extend underground even when the canopy looks still. The aging brain is like this forest, less hurried, more intentional, still alive with quiet construction. Across your lifespan, neurons continue adjusting their connections. Synapses strengthen and weaken based on use. New branches can still form on existing cells. Support cells remain active in maintaining healthy environments for signaling. The great shift is not from change to no change, it is from rapid change to measured change. Speed is not the same as possibility. When you are young, your brain is highly plastic partly because it is building foundational maps, language, movement, perception, social understanding. Later, many of those maps are already drawn. The brain becomes more selective about revisions, favoring stability where patterns prove reliable. This selectivity is efficiency, not failure. You might think of it as editing rather than drafting. Research shows that learning continues throughout adulthood and into later years. People acquire new languages, instruments, skills, and problem-solving strategies well beyond youth. Brain imaging reveals structural and functional adjustments accompanying this learning, not identical to childhood change, but real and measurable. The pathways respond when invited often enough. Invitation is the key word. Neuroplasticity responds to demand. When you challenge your mind gently, steadily, networks engage and adapt. When you withdraw challenge entirely, adaptation slows. This is not punishment, it is conservation. The brain is always managing energy. It invests where there is meaningful use. Curiosity acts like a renewal signal. When you approach something new with interest rather than pressure, neuromodulators associated with motivation and reward increase the brain's readiness to change. You can picture curiosity as opening windows in a quiet room, letting fresh air circulate through established circuits. Difficulty also plays a role, but only the right kind. Overwhelming difficulty produces stress responses that narrow flexibility. Mild, manageable challenge, what scientists sometimes call desirable difficulty, promotes stronger encoding and retention. It is like lifting a weight that is heavy enough to engage muscle, but not so heavy that movement stops. Your aging brain prefers this middle path. There are regions where new neurons can still appear across adulthood, particularly in structures involved in memory formation. This process is modest compared to early life, but it exists. More commonly, adaptation occurs through remodeling existing neurons, forming new synaptic spines, altering receptor sensitivity, changing firing patterns. Renovation rather than expansion. Blood flow patterns can change with training. Functional networks can reorganize, recruiting alternate routes to perform tasks when primary routes weaken. This is called compensation, and it is one of the brain's quiet triumphs. When one road becomes rough, traffic can be redirected through side streets. You have more detours available than you realize. Lifestyle factors influence how readily this flexibility expresses itself. Physical movement supports vascular health and releases growth-supporting molecules that encourage neural resilience. Sleep maintains cellular repair systems. Cognitive engagement, reading, problem-solving, conversation, creative work keeps networks active enough to justify maintenance. Social interaction is especially powerful. Dialogue requires rapid coordination between language, memory, emotion, and prediction systems. It is a full network exercise, rich and varied. Even gentle, regular conversation acts like cross-training for the brain. Stress, when chronic and unmanaged, can interfere with plastic processes by keeping protective chemistry elevated too long. But calm practices, breathing, reflection, steady routines help restore a biochemical climate where adaptation is easier again. Flexibility prefers safety. You might notice something reassuring here. None of these supports require intensity. They are rhythmic, humane, sustainable. Walks. Conversations. Learning small new things. Sleeping well. Paying attention. The brain responds more to consistency than to heroic bursts. There is also wisdom in the aging brain that youth does not yet hold. Pattern recognition improves across decades of exposure. Emotional regulation often strengthens. Decision-making can become more balanced as networks linking feeling and evaluation coordinate more smoothly. Plasticity is not only about speed of learning, it is also about depth of integration. Older networks are not empty highways. They are seasoned routes with rich signage. When people believe their brains cannot change, they often reduce effort, and reduced effort lowers stimulation, which lowers adaptation. Expectation shapes engagement, and engagement shapes structure. Hope, in this sense, is biologically useful. Believing in adaptability encourages the behaviors that support it. Right now, as you listen and imagine and understand, your brain is performing age-independent work, forming associations, updating models, integrating imagery with knowledge. These are plastic acts. They do not ask your birth year before proceeding. You are not required to learn like you did at 10 years old. You are invited to learn like you do now, with context, with patience, with meaning. Slower can be deeper. Fewer repetitions can still be enough when attention is present. The forest continues growing, even when growth rings tighten. As you rest with this, you may feel a soft release from urgency. Your mind is not racing a clock. It is tending a garden across seasons. And as you consider how pathways endure and adapt across time, another gentle question begins to rise. If learning continues, how exactly are your memories stored along these living paths? and what shapes which ones remain bright. You step now into a quieter region of your inner landscape, a place that feels less like a road system and more like a garden at night. Memory lives here not as a library of fixed shelves, but as living growth. It is organic, tended by attention, shaped by repetition, and nourished by feeling. You do not store memories like objects placed in boxes. You grow them like pathways through green space. Imagine walking through a garden under soft moonlight. Some paths are wide and clear, often traveled. Others are narrow, partly hidden by tall grass. A few are nearly invisible, waiting for a footstep to reveal them again. Your memories are like these paths. Each one is a pattern of neural activity that has been walked before and can be walked again. When you remember something, you are not opening a drawer. You are reactivating a route. Signals travel again across many of the same neurons and synapses that were active during the original experience. The pattern is never perfectly identical. It is a reconstruction, not a replay, but it is close enough to feel familiar. Like returning to a place where the trees have grown slightly taller since your last visit. This is why memory is flexible. Each recall is also a rewrite. Scientists call this reconsolidation. When a memory is reactivated, it briefly becomes changeable before settling again. New details can attach. Emotional tone can shift. Perspective can soften sharp edges. Memory is not fragile in a fearful sense, but alive in an adaptive sense. It updates as you update. There are different gardens within the larger one. Some memories are episodic, scenes from your life, moments with location and sequence and sensory detail. Others are semantic knowledge, meanings, concepts not tied to a single event. Others are procedural, skills and habits your body knows how to perform without step-by-step awareness. Each type grows along somewhat different neural beds, though they overlap and cooperate. Remembering a bicycle ride uses different primary circuits than remembering the definition of a word, yet both draw from shared support systems of attention and association. At the center of new memory formation is a structure shaped like a curled leaf, deeply placed within your brain. It helps coordinate the first planting of new episodic memories, linking together sights, sounds, feelings, and context into a coherent pattern. Over time, with repetition and sleep, many memories become less dependent on this central planter and more distributed across the wider cortex, like vines spreading onto many trellises. Distribution is protection. It allows resilience. Emotion acts like water in this garden. Experiences charged with feeling joy, fear, surprise, love tend to be encoded more strongly. Chemical signals released during emotional arousal adjust how readily synapses strengthen. It is as if certain plants receive extra watering during their first days of growth. They take root more firmly. This is why emotionally meaningful moments often feel vivid years later, while neutral details fade. The brain is not trying to be sentimental. It is being practical. Emotion often signals importance for survival or belonging, so the system prioritizes it. Repetition is sunlight. When you revisit information by reviewing, practicing, retelling, you expose those neural plants to light again. Photosynthesis of the mind begins. Synaptic efficiency increases. Supporting connections form. What was once fragile becomes sturdy. Spacing matters here too. When repetition is spread over time, growth is stronger than when crowded together. A plant watered regularly thrives more than one flooded once. Your memory systems respond to rhythm. Forgetting is not a failure of the garden. It is part of its design. If every experience were preserved with equal strength, your mental landscape would become overgrown and inefficient. Forgetting clears space. It reduces noise. It allows general patterns to remain while unnecessary detail dissolves. Pruning supports clarity. Sometimes forgetting feels frustrating, but it is also functional. Your brain keeps what is used, meaningful, or revisited. It lets go of what remains untouched. You are not losing your mind when small details slip away. You are refining your garden. Context acts like soil type. Memories attach more easily when new information connects to what you already understand. Rich soil grows stronger roots. This is why analogy and story help learning. They provide existing structure for new growth to cling to. Nothing grows well in isolation. Sleep is the night gardener. During sleep, especially deeper stages, recently activated memory patterns replay in compressed bursts. Networks coordinate quietly, strengthening useful connections and integrating them with older knowledge. Chemical conditions shift to favor consolidation. It is like workers moving through the garden in darkness, reinforcing edges of paths you walked during the day. Dreaming may sometimes weave fragments of these reactivations into images and narratives. Not every dream is a memory rehearsal, but memory rehearsal often happens during dreaming states. The mind practices softly while you rest. Stress can change how memories grow. Acute stress may intensify encoding of central details while reducing peripheral ones. Chronic stress chemistry, however, can interfere with healthy planting and retrieval if it remains elevated too long. Calm restores balance, allowing broader, more flexible memory networks to function again. Retrieval itself strengthens memory. Each successful recall is another walk down the path, pressing it firmer. Even attempted recall, searching and reconstructing, activates helpful circuits. Testing yourself gently is like sending explorers through the garden to keep trails open. You might notice that cues help you find memories: a smell, a song, a location. These cues are like signposts at path entrances. They activate part of the pattern, which then spreads activation to the rest. The more cues attached during learning, the more entry points later. Your sense of identity grows from this garden of memory. Not from perfect recall, but from stable patterns, themes, values, repeated experiences that form well-tended groves. You are not defined by every fallen leaf, but by the living structure that remains. As you rest here, you may feel gratitude for the quiet tending always underway inside you. Paths being reinforced. Excess being trimmed. New seeds being placed from today's moments. And as you consider how memories are planted, strengthened, and revisited, another gentle curiosity begins to open: how the movement of your body and the rhythm of your breath might feed this garden from below, like hidden rivers nourishing the roots. You begin to notice now that your brain is not floating alone in darkness. It is not a separate machine sealed away from the rest of you. It is held, fed, cooled, and tuned by your body, by your heartbeat, your breath, your muscles, your movement. The map inside your mind is connected to the rhythm of your steps and the tide of your lungs. You can imagine your body as a landscape of rivers and roads, all quietly supporting the bright cities of your neurons. With every heartbeat, blood travels upward carrying oxygen and glucose, the essential fuels of neural activity. These supplies are not stored in large reserves inside the brain. They are delivered continuously, like fresh shipments arriving just in time. When you move your body, these deliveries increase. Even gentle motion, walking, stretching, slow shifting raises circulation slightly. Blood vessels widen. Flow improves. More oxygen reaches active tissue. Waste products are cleared more efficiently. This is not dramatic like a storm. It is more like opening irrigation gates a little wider so fields drink more easily. Neurons are energy-hungry cells. They maintain electrical gradients across their membranes at all times, like tiny batteries always charged. Sending signals costs energy. Resetting after signals costs energy. Building and reshaping synapses costs energy. Movement helps pay this quiet bill. There is also chemistry released during physical activity that acts like fertilizer for the brain. Certain growth-supporting molecules increase in availability, encouraging synaptic plasticity and cellular resilience. You can think of these as renewal messengers, gentle notes that say, conditions are good for adaptation. Intensity is not required for benefit. Consistency matters more than strain. A calm daily walk sends steadier signals of support than a single exhausting effort followed by long stillness. The brain prefers rhythms it can trust. Breath works beside movement as a second tuning system. Your breathing is both automatic and adjustable, a rare bridge between conscious and unconscious control. When your breath is shallow and rapid, it often accompanies alert or stressed states. When it is slow and deep, it signals safety and restoration. These patterns are not merely emotional, they are neurological. Slow breathing influences the balance of your autonomic nervous system, the network that regulates heart rate, digestion, and baseline arousal. Longer exhales in particular are associated with increased parasympathetic activity, the branch linked with calm and repair. When this branch is active, conditions favor neural maintenance and flexible responding rather than defensive urgency. You can picture breath as a metronome for your inner orchestra. Neural rhythms tend to coordinate with bodily rhythms. Subtle oscillations in brain activity can synchronize with breathing cycles, especially in networks related to attention and emotion. Each slow inhale and exhale becomes a timing signal, a gentle conductor's gesture guiding tempo. Carbon dioxide and oxygen levels in your blood shift slightly with each breath, and these shifts influence blood vessel diameter in the brain. Slow, steady breathing can support stable cerebral blood flow. Not forced, just even. Smooth like waves reaching shore. Posture also speaks to your brain. Sensory receptors and muscles and joints continuously report body position upward through spinal pathways. These signals influence alertness networks and spatial processing regions. Upright posture tends to support wakeful attention. Reclined, supported posture supports relaxed inward focus. Your body tells your brain what kind of state is appropriate. Movement adds variation to this sensory conversation. When you change position, new signals arrive. Balance systems update. Coordination networks engage. Even small adjustments are informational. The brain enjoys informative input. It stays more adaptable when gently stimulated from many channels. There is a graceful loop here. The brain guides movement, and movement feeds the brain. Learning physical skills, even simple ones, builds coordination between motor regions, sensory regions, timing circuits, and predictive models. Practice strengthens these loops. With repetition, movements become smoother because neural timing improves and unnecessary activity is reduced. Efficiency grows. You might find comfort in knowing that mental fatigue sometimes lifts with physical motion because circulation, chemistry, and sensory input all refresh neural networks at once. A short walk can feel like opening windows in a warm room. Stillness has its place too. Deep rest allows energy stores to replenish and repair processes to proceed. But rest and movement are not opposites in conflict, they are partners in cycle. Like tide and shore. Movement stimulates, rest integrates. Movement delivers, rest rebuilds. Even very subtle movement, the slow expansion of your ribs as you breathe, participates in renewal. Nothing is too small to matter biologically. Your systems are sensitive to pattern more than magnitude. Hydration supports this entire exchange. Blood volume and flow depend on fluid balance. Cellular processes depend on water as a medium. Gentle, regular hydration helps maintain the transport network that keeps neurons supplied and stable. Again, small, steady habits matter. You may notice that many practices associated with mental clarity, walking outdoors, stretching, breathing slowly, mindful movement, are not mysterious techniques but direct biological supports. They align body rhythms with neural needs. They create favorable conditions rather than forcing outcomes. Right now, as you listen, your breath continues its quiet tide. Your heart continues its steady pulse. Signals rise from your body to your brain and return again in seamless exchange. You are not a mind inside a body. You are a conversation between them. If you wish, you can feel one slow breath now, not changing it, just noticing it, and imagine that with each exhale, space opens in your neural garden, and with each inhale, fresh nourishment arrives. And as this rhythm settles, another gentle curiosity begins to form. What happens to all these pathways and signals when you drift fully into sleep, and who tends the circuitry while you are gone from waking awareness? You arrive now at the edge of sleep, not as an ending, but as an entrance. Sleep is not a shutdown. It is not your brain switching off the lights and locking the doors. It is more like a night shift beginning, when different crews step quietly onto the floor and begin careful, essential work. From the outside, sleep looks like stillness. From the inside, it is structured activity, moving through repeating stages like gentle tides. Your brain changes rhythm, changes chemistry, changes priorities, but it does not go silent. It turns inward. You can imagine your waking brain as a busy city in daylight, traffic moving, messages flying, decisions being made. Sleep is the same city at night, when maintenance teams close certain roads, clean the streets, repair the wiring, and archive the day's records. As you drift into deeper sleep, large groups of neurons begin to fire in slow, synchronized waves. These are often called slow waves, broad, rolling patterns of activity moving across the cortex. Instead of fast, detailed signaling, the brain shifts into coordinated pulses. It is like the difference between rapid conversation and slow breathing. These slow waves are restorative. They are associated with energy recovery inside neurons and with recalibration of synaptic strength. During waking hours, many connections strengthen as you learn and respond. If they all kept strengthening without balance, the system would become noisy and inefficient. Deep sleep helps renormalize, gently scaling back overall synaptic intensity while preserving important relative differences. You can picture it like tuning an instrument after a long performance, tightening here, loosening there, so tomorrow's music is clear again. There is also a cleaning system that becomes more active during sleep. Fluid channels surrounding blood vessels in the brain allow cerebrospinal fluid to circulate more freely when neural activity patterns shift and certain support cells change shape. This circulation helps clear metabolic byproducts that accumulate during waking activity. It is like a nighttime rinse cycle, washing away residue from a day of signaling. You do not feel this washing, but it matters. Memory processing is another major night task. Patterns of neural activity that occurred during learning are replayed in compressed bursts during sleep, especially in certain deeper and intermediate stages. Regions involved in forming new memories coordinate with broader cortical networks, gradually distributing and stabilizing traces. It is as if your brain whispers the day's lessons to itself, over and over, until they settle into long-term structure. Different kinds of memory benefit from different sleep phases. Declarative memories, facts, and events are often supported by deep, slow-wave-rich sleep. Skill memories and emotional learning are strongly associated with periods of sleep that include rapid eye movement, or REM, when brain activity becomes more varied and dream imagery is common. REM sleep is a fascinating state. Your brain shows patterns that, in some ways, resemble waking activity, yet your body is largely prevented from moving, held in protective stillness by brainstem mechanisms. Sensory input from the outside world is reduced, while internally generated imagery increases. Networks that combine memory, emotion, and imagination interact freely. Dreaming often lives here. Dreams are not random noise, though they are not simple recordings either. They are constructed experiences, drawing from memory fragments, emotional themes, and predictive models. Some researchers believe dreaming helps integrate new learning with older knowledge and simulate possibilities in a low-risk environment. You can think of dreams as a kind of gentle rehearsal stage. Emotion regulation also benefits from sleep. Brain regions involved in emotional reactivity and those involved in regulation recalibrate their relationship overnight. After sufficient sleep, emotional responses tend to be more balanced and less extreme. It is as if sleep restores the volume controls between feeling and evaluation. Hormone patterns shift across the night as well. Growth-supporting hormones rise during early deep sleep. Stress-related hormones follow their own rhythms, ideally lower in early night and rising toward morning readiness. These cycles support cellular repair and metabolic balance throughout the nervous system. Timing matters. Regular sleep schedules help align internal clocks, circadian rhythms that coordinate temperature, hormone release, alertness, and gene expression across tissues. When timing is consistent, the night shift knows when to begin and what to expect. Irregular timing makes the work less efficient. Light exposure influences this clock strongly. Darkness signals preparation for sleep chemistry, including the release of melatonin. Soft evening light and reduced stimulation support smoother transitions. Again, the brain prefers gradual change over abrupt command. You might feel comfort in knowing that even if a single night is imperfect, recovery processes resume the next time you sleep. The system is resilient. It does not abandon maintenance because of one delay. It simply continues when allowed. Short rest periods can include lighter versions of these processes too. Even brief naps can support memory consolidation and alertness, though full cycles bring fuller restoration. The architecture is layered, like nested rhythms. Right now, as you approach sleep, your neural networks are already beginning to shift modes. Sensory gating increases. Internal imagery becomes easier. External demands loosen their hold. You are moving from outward conversation to inward tending. Nothing you must direct. Nothing you must monitor. The night crews know their roles. You might imagine them now, quiet caretakers walking the glowing pathways, reinforcing useful bridges, clearing debris, adjusting signal strength, filing today's experiences into tomorrow's readiness. And as this hidden work continues each night without your supervision, another gentle question begins to glow. If sleep restores and resets your circuits, what happens when something new and unexpected enters the system, lighting unfamiliar pathways you have never walked before? You rest now in a quieter mental space, and from this calm you notice something subtle. Your brain is drawn to the new, but not in the way of noise or shock. It is drawn to gentle novelty, like a traveler noticing a lantern glowing where yesterday there was shadow. Curiosity is not a storm in your mind. It is a small, steady flame. Your nervous system is designed to detect difference. Change in pattern, change in sound, change in image. These variations create soft signals that say, "Look here." Not urgently. Not fearfully, unless danger is present. Simply attentively. Novelty is information, and information is opportunity for adjustment. When something new appears in your experience, certain brain networks increase their alertness. Comparison systems evaluate the difference between expectation and reality. Prediction circuits update their models. Attention shifts slightly toward the unfamiliar feature. This shift is one of the engines of learning. You can imagine your brain as a careful mapmaker. Each time reality differs from expectation, a small correction is penciled in. Mountains move a little. Rivers bend. Boundaries refine. Without novelty, the map grows stale. With gentle novelty, it stays accurate. Chemistry participates in this process. When you encounter something interesting or unexpectedly rewarding, motivation-related messengers increase their activity. These signals do not simply create pleasure, they increase plastic readiness. They make synapses more willing to adjust. It is like lightly moistening clay before shaping it. Curiosity, then, is biologically practical. It prepares the tissue for change. Importantly, novelty does not need to be dramatic. Your brain responds well to small variations: a new route walked slowly, a new idea considered, a new skill practiced briefly, a new perspective heard. Tiny differences are easier to integrate than overwhelming ones. A whisper teaches more gently than a shout. Large shocks can narrow flexibility by triggering strong stress responses. Mild surprise widens it. The optimal zone for learning is often calm interest, alert, but not alarmed. You might think of curiosity as opening windows rather than breaking walls. There are networks in your brain that especially support exploratory attention, circuits that balance internal focus with outward noticing. When curiosity is active, these networks coordinate with memory and reward systems, linking new input with existing knowledge. Bridges form between regions that do not always speak closely. Integration increases. This cross-network conversation is one reason novelty supports creativity. When unfamiliar combinations appear, your brain searches for connections. It tests metaphors. It blends patterns. It asks quietly, "Where have I seen something like this before?" Meaning grows at intersections. Children show this process vividly: constant exploration, constant model updating. Adults retain the same mechanisms, though habits and routines often reduce how often they are invited. Routine is efficient and comforting, but too much uniformity lowers exploratory signaling. The map stops stretching. Balance is the art, steady ground with occasional new paths. Even imagination can provide useful novelty. When you vividly imagine a new movement or idea, many of the same neural circuits activate as in real experience. Mental simulation is a low-risk way to introduce variation. Athletes, musicians, and scientists alike use this principle. The brain practices possibility before reality arrives. Questions are tools of curiosity. When you ask a gentle question, "How does this work?" What would happen if you orient attention toward discovery? Questioning shifts your brain from confirmation mode to exploration mode. Prediction loosens slightly. Openness increases. Curiosity also reduces fear responses when applied softly. When you approach uncertainty with interest rather than threat, emotional centers signal less alarm, and cognitive networks remain more flexible. You might notice this in yourself. Naming something as interesting changes how it feels compared with naming it as dangerous. Social novelty matters too. New conversations, viewpoints, and stories introduce pattern variation your brain cannot generate alone. Other minds are sources of structured surprise. Dialogue is shared exploration. Nature provides gentle novelty continuously, changing clouds, shifting light, subtle sound variation. This may be one reason natural environments often feel mentally refreshing. They are varied without being overwhelming. Complexity with calm. There is also a timing effect. Novelty earlier in learning increases later retention by raising plastic readiness. A brief interesting element at the beginning of study can improve how well material is encoded afterward. It is like ringing a small bell before speaking. The room grows attentive. You do not need to chase constant newness. The brain does not require endless stimulation. It prefers meaningful variation nested within stable rhythms. Too much novelty becomes noise. Too little becomes stagnation. Gentle sparks, spaced in time, keep networks responsive. Right now, even this inward journey is a kind of novelty, thinking about your own brain as landscape, garden, conversation, workshop. Metaphor itself is novelty, linking known and unknown. Each analogy builds a bridge between networks. You are experiencing plasticity through imagery. You might ask yourself, softly, what is one small new thing you could welcome tomorrow? Not a life overhaul. Just a variation. A different question asked. A different route walked. A different idea explored for 5 minutes. Small doors open wide neural rooms. Curiosity does not demand speed. It invites noticing. As you grow more comfortable with novelty, your tolerance for learning stretches. Unfamiliar signals feel less threatening, more informative. Flexibility increases. The map becomes easier to revise. Adaptation feels more like play than pressure. And as these gentle sparks of newness light different corners of your neural landscape, another contrast begins to appear. What happens when the signals are not sparks but storms, when pressure and stress alter the pathways instead of curiosity, and how calm can reshape them again? You settle now into an awareness of rhythm, the rhythm of thought, the rhythm of your body, and the rhythms of your inner climate. There is warmth and ease here, but you notice something else too, the subtle storms that sometimes move through your mind. Stress is one of these storms. It is neither enemy nor failure, it is a natural signal, a shifting pattern of signals and chemicals flowing across your circuits. You can picture it as weather moving across a landscape. Clouds gather, winds shift, perhaps rain falls. Storms change visibility and movement. Your mental weather is similar. Under stress, neural circuits can tighten, firing more rapidly and selectively. Certain regions, especially those related to survival and rapid response, become dominant. Other networks, associated with reflection, exploration, or calm, recede temporarily. This is not a permanent shift, it is functional, a way your system mobilizes attention, energy, and readiness. The challenge is balance. Frequent storms, or prolonged pressure, can make the brain favor reactive pathways. Connections that were flexible may harden, like paths compressed under repeated traffic during a flood. The landscape adapts to repeated conditions, for efficiency and survival. But the same adaptation that helps in acute stress can become limiting if the storm continues too long. You may notice how bodily signals participate in this process. Heart rate rises, muscles tense, breathing quickens. Hormones circulate, signaling that action is needed. These physiological changes feed back into your brain, amplifying alertness, narrowing attention. You are a full system, responding in concert. Yet calm is equally natural. When the storm passes or is softened, pathways that had narrowed can relax. Neural circuits responsible for reflection, creativity, and broader consideration regain influence. Neurotransmitter systems that promote flexibility, learning, and connectivity become more active. Blood flow stabilizes. Breathing deepens. Muscles loosen. This is your restorative rhythm. Safety is the foundation. The nervous system gauges context. In safe environments, it allows flexible processing. In unsafe ones, efficiency and rapid response dominate. You can imagine this as the difference between a windy ridge and a calm meadow. The meadow invites wandering. The ridge encourages careful steps. Both landscapes have value, one is expansive, the other focused. Your breathing can gently guide this balance. Slow, deep inhalations, followed by smooth exhalations, signal your nervous system that conditions are safe. Even without conscious effort, this rhythm lowers arousal markers, reduces stress hormones, and increases parasympathetic activity, the branch associated with rest and repair. You are influencing the shape of thought through nothing more than gentle rhythm. Routine also plays a role. Predictable sequences of actions provide a stabilizing anchor. Neural pathways involved in habitual behavior and timing are reinforced, which allows more cognitive space for adaptation elsewhere. Calm, consistent activity is like sunlight warming soil, it encourages resilience without force. Attention matters. Noticing stress without judgment allows you to observe its movement without feeding its intensity. Awareness acts as a moderator, signaling that storms are temporary and contextual. Networks in the prefrontal cortex and hippocampus interact to assess reality versus threat. You can watch your mental weather, not as a victim, but as a participant. Emotion is intertwined here. The amygdala, the center of alert and emotional salience, communicates constantly with higher-order processing areas. Stress amplifies this dialogue. Calmness modulates it. Repeated experiences of safe, mindful engagement teach the system that flexibility is possible. This learning reinforces itself. Circuits that experience stability tend to support stability more efficiently in future moments. You might picture neurons as tree branches. Under wind, they bend and sway, sometimes creaking, sometimes tapping against each other. When the wind ceases, they settle into gentle sway again. The branches remember how to flex, they are not broken. Similarly, your brain retains memory of flexibility even after stress passes. What is tightened can relax. Sleep enhances this renewal. Deep and REM sleep facilitate recalibration of neural circuits, integrating experiences, regulating emotion, and repairing metabolic strain. Cortisol patterns shift during sleep, allowing clearance and reset. The night becomes a natural moderator of mental storms, balancing responsiveness with adaptability. Even micro-moments of calm, noticing your breath for a minute, feeling the chair beneath you, listening to a soft sound, support flexible wiring. These are not dramatic interventions. They are subtle reminders to your nervous system. The environment is safe enough to allow re-expansion. Neural pathways are fluid, responsive to gentle signals of reassurance. Stress is not only a challenge, it is a teacher. Mild stress paired with calm recovery can strengthen resilience. Just as a tree sways in wind and becomes sturdier at the base, temporary mental pressure followed by relaxation improves the system's ability to respond without rigidifying. Adaptation requires both tension and release, challenge and safety. You might notice how thought itself shifts under these conditions. Under stress, ideas feel narrower, focus tight, creativity harder to reach. In calm, attention broadens, associations emerge, insight appears. You can literally feel the difference in the landscape of your mind. The roads that were compressed loosen. Trails that had narrowed open. Connections that had seemed distant whisper their presence again. Breath and movement remain allies. Gentle stretches, slow walking, or conscious attention to posture subtly cue neural networks that stress has softened. Circulation and oxygenation improve. Neurochemistry adjusts. The effect is cumulative. Small interventions repeated over days shape the brain more than rare, intense efforts. Curiosity fits here as well. When you maintain interest in your surroundings or in learning, even lightly, flexible networks gain reinforcement. Exploration in safe contexts signals that adaptation is both useful and enjoyable. Calm allows novelty to be processed optimally, while stress narrows it. Integration is key. Memory, attention, emotion, and executive planning interact constantly. Stress and calm are not isolated phenomena. They shape the way these networks communicate, the pathways they prefer, the routes that become more reliable. Each wave of tension and each wave of ease leaves traces, sometimes small, sometimes profound, that influence future experience. You might imagine your brain as a garden of pathways. Stress is wind bending the stems, perhaps snapping some twigs. Calm is sunlight, steady moisture, hands carefully pruning or guiding growth. Both are part of the ecosystem. Both shape form. Neither is final on its own. Flexibility persists beneath surface impressions. Now, as you breathe slowly and feel your body settle, you may sense pathways softening. Tightened circuits gently relax. You can imagine neural traffic resuming a wider, more thoughtful flow. Reflection, creativity, and memory begin to reassert themselves quietly. Stability returns to places that had felt tense or constricted. And as this sense of equilibrium deepens, another soft question arises: if calm restores flexibility and stress narrows it, how might your daily rhythms, your choices of attention, movement, and rest, continuously sculpt the terrain of your mind, shaping the ease with which curiosity, memory, and learning flow tomorrow? You rest in the quiet reflection of what you have discovered so far, the living map of your mind, the pathways shaped by attention, the renewal provided by body and breath, the gentle sparks of curiosity, and the calming influence that opens flexible circuits. Now, your awareness turns to the timeless question of learning. How does it unfold across a lifetime, and what does it feel like when the clock is no longer an authority but merely a companion? Learning is not a race against time. It does not demand a starting line, nor does it require a particular finish. Your brain, as you have felt, retains its capacity for adaptation, not as a youthful sprint but as a patient journey. The circuits that underpin learning continue to respond to experience, guided by repetition, attention, and emotion. Age is context, not limit. Imagine a river carving its path through varied terrain. In youth, the river may rush quickly, responding immediately to every incline. Later, the water flows more deliberately, carving deep channels through rock and soil with persistence rather than speed. Its course is shaped by time, yes, but not prevented by it. In learning, you are that river, slower, steady, resilient. Growth depends more on engagement than chronology. Every time you choose to notice, to explore, to practice, to attempt, you send signals across neural networks that encourage plastic change. Repetition strengthens paths, as you have discovered, and attention directs the growth where it matters. Motivation and curiosity fertilize the soil. When these elements combine, learning occurs. Age does not abolish this process, it merely adjusts its tempo. Practice becomes nourishment rather than pressure. Consider an instrument you have never played. Each time you touch it, a small neural trail is built. At first, movements may be clumsy, notes uncertain. Yet with gentle, consistent practice, circuits strengthen. The rhythm of practice matters more than the duration or intensity. Tiny, steady repetitions are like steady rainfall nourishing roots. Mistakes are part of this ecosystem. They are not walls blocking your progress but stones along the path, markers that guide recalibration. When you err, your brain signals what is unexpected. Pathways adjust. Timing improves. Predictive models refine. You may even notice subtle pleasure in correction, a quiet sense of mastery emerging from trial and return. Memory integrates with learning across time. Earlier lessons, earlier experiences, and emotional context all interact to shape current acquisition. Your brain does not start fresh each day. It layers new learning atop old scaffolding. Knowledge is cumulative, but it is also flexible. Pathways can be rewired, connections rerouted, patterns reshaped. Nothing is ever fully closed. The map continues to evolve. Curiosity is your most reliable guide. When you approach new information with interest, circuits associated with attention, motivation, and memory engage simultaneously. These networks coordinate to maximize the likelihood of adaptation. Even a small spark of curiosity can catalyze substantial change. Novelty paired with interest opens doors that repetition alone cannot. You are a lifelong learner when you allow yourself to notice what intrigues you. The rhythm of learning is important. Spaced repetition, gentle review, interleaved practice, these are not arbitrary rules. They align with the natural pacing of synaptic consolidation and network remodeling. Sleep continues to play a supporting role, stabilizing new memories and integrating them with existing knowledge. Even rest periods, when combined with attention and reflection, solidify pathways. Learning is woven through cycles of effort and restoration. Social learning enhances this process. Conversations, shared experiences, mentorship, and collaboration provide diverse inputs. Other minds introduce subtle variation, reinforcing flexible connectivity and prompting creative associations. When you engage with another person, you are participating in cross-network stimulation. These interactions enrich patterns, providing scaffolding that solitary effort alone cannot fully supply. Emotion remains essential. Positive emotional tone facilitates stronger encoding and integration. Feeling safe, curious, and motivated produces chemical conditions that support plasticity. Conversely, excessive pressure, fear, or discouragement narrows circuits, making learning more laborious. The emotional climate you cultivate around your efforts is as influential as the practice itself. Reflection complements active learning. When you pause to notice patterns, recall what you have absorbed, and consider connections, you allow networks to consolidate in a more integrated manner. Reflection is a gentle rehearsal, a quiet dialogue between past and present, weaving coherence through distributed circuits. It is a soft act of synthesis that makes knowledge more accessible in future moments. Adaptation is continuous. The brain does not set a deadline for capability. Even in later years, synaptic remodeling, dendritic branching, and circuit reorganization persist. Some changes occur more slowly, some require more repetitions, but the potential remains. You are not bounded by a singular timeline. You are bounded only by engagement and opportunity. Confidence grows with experience. Not in certainty alone, but in knowing that attempts, mistakes, curiosity, and reflection all contribute to real change. Each step, each small encounter with the unknown strengthens the internal map. You begin to sense the pathways, the patterns, and the rhythm of your own learning process. You understand that growth is iterative, patient, and cumulative. Even physical activity supports this learning. Movement increases cerebral blood flow, enhances oxygenation, and releases molecules that aid synaptic remodeling. Body and mind are in dialogue, each enhances the other. Attentive practice, whether mental, physical, or emotional, integrates the whole system, reinforcing coordination across multiple networks. Integration extends to identity as well. You are not learning in isolation, you are learning as a self with history, preferences, and goals. The pathways you build are colored by meaning and context. Relevance ensures retention. The brain responds more readily when patterns resonate with purpose, when repetition is paired with understanding, and when engagement is accompanied by curiosity and care. You may notice a sense of liberation in this knowledge. The clock is not your master. Age is information, not judgment. The rate of learning adjusts, yes, but the capacity to expand, adapt, and integrate endures. You are free to continue exploring, practicing, and noticing, confident that each small act contributes to structural and functional growth. Right now, as you rest in awareness of this unfolding, you might sense a subtle internal excitement, not urgency, not pressure, but a gentle recognition of ongoing possibility. Every thought, every new idea, every attentive observation sends a ripple across circuits, quietly reshaping, reinforcing, and integrating. Even while you drift toward rest, your mind is readying for the next day's small encounters, the next layer of learning. You are a lifelong learner. Not by obligation, not by sprint, but by the rhythm of curiosity, attention, and gentle engagement. Every step, no matter how small, adds to the map. Each practice, each reflection, each mindful moment is a stone in the path of understanding. And mistakes, when embraced, are bridges to deeper insight rather than walls of limitation. And as you sense the continuity of growth, the adaptability that stretches beyond age, and the quiet, patient rhythm of learning that never ceases, another thought gently stirs. If engagement fuels plasticity and curiosity opens new paths, then what unseen networks are quietly waiting tonight, ready to integrate tomorrow's experiences into the ever-evolving tapestry of your mind? You move now into a quieter awareness of connection, the unseen threads linking your mind to others. Your brain is not isolated. From the earliest moments of life, it has evolved to be a social organ. The neurons in your head thrive not only on attention and curiosity, but also on interaction, collaboration, and exchange. Each encounter is more than words or gestures. It is a dialogue between networks, a subtle communication across invisible pathways. You can imagine your mind as a garden, and the presence of others as wind, water, and sunlight. They shape growth, bring nutrients, and sometimes introduce gentle disturbances that encourage flexibility. Neural circuits respond to social input just as they respond to novelty or movement. Faces, voices, expressions, shared attention, all of these provide stimuli that guide the strengthening or weakening of connections. Mirror neurons are one example. When you observe someone performing an action or experiencing emotion, certain neurons in your brain activate as if you were performing or feeling it yourself. This is not imitation alone, but a form of internal simulation. You are, in a subtle way, walking through their experience, mapping it into your own networks. The more you engage empathetically, the richer and more integrated your circuits become. Conversation works similarly. When you discuss, explain, or debate, your brain organizes and organizes again. You must recall information, evaluate relevance, anticipate response, and adjust tone and timing. This activates networks of memory, attention, language, and executive function simultaneously. You are exercising your mind across multiple domains at once, weaving new connections. Even passive social observation matters. Watching interactions, noticing patterns of expression, tracking subtle emotional cues, these all influence your neuroplasticity. Your brain models others' behavior, predicts outcomes, and learns possibilities without direct action. It is quietly preparing for future interaction. Connection also provides safety signals. When you feel understood, accepted, or supported, circuits associated with stress decrease their activity. Oxytocin, sometimes called the bonding hormone, flows gently, reinforcing trust and approach behaviors. These chemical cues do not guarantee perfection, but they provide fertile ground for learning and adaptation. Flexibility thrives in safety. Belonging is restorative. Communities, friendships, mentors, even brief positive interactions all signal a stable environment. When you feel connected, rigid patterns relax, and circuits associated with exploration, problem-solving, and creativity regain influence. Social nourishment is subtle but persistent, like sunlight warming the roots of a tree over days and weeks. Even disagreements, when approached constructively, shape flexibility. Encountering perspectives different from your own requires networks to evaluate novelty, revise predictions, and sometimes update beliefs. Mental rigidity softens when new viewpoints are integrated gently. Debate is not only about correctness, it is about the soft stretching of neural fabric, the expansion of potential pathways. Language itself is a tool for shaping thought. Words you hear, words you speak, words you read all interact with semantic and syntactic networks in the brain. Vocabulary is not mere label, it structures perception. Shared language provides shared architecture, allowing minds to align, understand, and innovate together. Each conversation is a bridge spanning neural landscapes. Emotion is also social. Shared laughter, empathy, reassurance, or subtle encouragement reinforces circuits that connect reward, attention, and social cognition. Positive emotional exchanges strengthen bonds and the adaptability of related networks. Even small expressions of kindness ripple through the system, shaping responses long after the moment passes. You may notice that social interaction often accelerates learning. The brain thrives when novelty is paired with context, meaning, and feedback. Conversation supplies these elements. Explanation consolidates memory. Storytelling provides context. Feedback corrects errors. Social engagement is a rich scaffold for plastic change. Observation reveals patterns. Your responses are shaped by recurring interactions. Supportive relationships encourage growth. Negative or high-stress environments can constrict flexibility. This is not absolute, but probabilistic. The repeated signals of trust and safety lay foundations for adaptive circuitry, while repeated threats or criticism make pathways more defensive, tighter, less exploratory. Even solitary reflection is social in subtle ways. You carry internalized voices, mentors, teachers, friends, and past conversations. Mental rehearsal of dialogues, imagining perspectives, and internal storytelling activate similar neural networks as actual interaction. Your social brain remains active even in silence. You can sense this in your awareness. Some voices, ideas, and interactions open doors. Others close them gently, guiding you toward caution. Curiosity is tuned by context. Attention follows patterns that feel safe and informative. You are continuously calibrating, not just alone, but in the company of echoes from others. Your social brain also interacts with memory and emotion. Shared experiences anchor memories more strongly. Emotional resonance amplifies learning. When something meaningful is experienced with others, neural reinforcement is greater. These moments become landmarks, pathways that remain accessible for years. Connection and memory intertwine. There is also subtle cross-pollination. Observing someone's approach to problem-solving can inspire new strategies in your own network. Hearing a story can provide frameworks that your own imagination expands. Social influence is often gentle, cumulative, and integrative, not coercive or abrupt. Even digital connections have impact. When you engage thoughtfully online, reading, responding, collaborating, similar networks are recruited. The principle remains: meaningful engagement, paired with attention and reflection, promotes growth. Noise and passive scrolling, however, have less effect. The quality of interaction matters more than quantity. You may feel gratitude for this internal social landscape. Your mind is shaped by both present and past interactions, by voices you encounter and those you carry internally. You are not isolated, you are in continuous dialogue with the world and its people. Every conversation, every observation, every attentive connection contributes to the structure and adaptability of your mind. As you breathe and rest here, consider which voices foster your growth and which interactions support flexibility. Which conversations have opened neural doors? Which moments have strengthened pathways of understanding, empathy, and creativity? You begin to notice subtle preferences, patterns that quietly guide your engagement. You might sense a gentle invitation to continue cultivating relationships that enrich your neural landscape, to allow curiosity and attentiveness to guide interaction, to notice where stress or conflict might tighten pathways and where reassurance and trust might relax them. Your social brain is alive and responsive, quietly shaping who you are and who you may become. You arrive now at the gentle conclusion of this journey, a place where your mind can rest and yet continue its quiet, ongoing work. Even in stillness, your brain is alive, a dynamic landscape of shifting circuits, softly glowing synapses, and pathways gently remodeling themselves. You do not need to direct this change, it happens beneath your awareness, like moss growing slowly along a shaded rock, or tides moving silently beneath a moonlit sky. Even in moments of apparent calm, neurons continue their conversation. Electrical signals flicker across networks, carrying information, consolidating memories, integrating new learning, and pruning connections that are no longer needed. Dendrites extend, synapses strengthen, others weaken, all in a subtle choreography that keeps your mind flexible and responsive. This process does not pause, not even when you sleep. Change continues as a quiet hum, a soft background rhythm to your awareness. Small, repeated habits, the choices you make daily, the rhythms you honor, the practices you engage in, become lifelong sculptors of your mind. Gentle repetition, consistent attention, mindful reflection, movement, curiosity, and social connection all leave their mark. These are not dramatic interventions, they are subtle, cumulative, enduring. Like water slowly carving stone, they shape neural landscapes over time. Your awareness itself participates in this sculpting. By noticing thoughts, patterns, and responses without judgment, you create space for flexible adjustment. By breathing and moving attentively, you feed the brain's networks. By welcoming curiosity, you spark growth. By resting and reflecting, you allow integration. Each gentle act adds to the invisible architecture of your mind. Memory continues to reorganize quietly, even as you rest. Experiences are consolidated, emotional tone is balanced, and lessons from the day are woven into the fabric of knowledge. Sleep and stillness act as partners in this process, orchestrating the delicate balance between preservation and adaptation. The work is subtle, but its effects are profound. Over time, your neural map becomes richer, more resilient, more capable of supporting new exploration. Even the smallest changes are meaningful. When you adjust your posture, take a slow breath, notice an idea, or try a new approach to a task, your brain responds. Each microaction sends ripples across networks, gently adjusting connections and probabilities. You do not need to force mastery or dramatic change. The cumulative effect of small, thoughtful acts shapes adaptability and resilience in profound ways. Your mind also preserves continuity amidst change. Core patterns, deeply integrated knowledge, and learned skills provide stability, while more flexible circuits continue to explore, adapt, and integrate. This balance of constancy and flux allows you to respond to novelty, stress, and challenge with both wisdom and agility. You are not static, you are resilient. You are both structure and flow. You might imagine your brain as a forest at twilight. Some trees are firmly rooted, providing shade and shelter. Others are young saplings, stretching toward the light, bending with the wind, learning where to grow. Between them, a network of roots, fungi, and soil communicates, nourishing life in subtle, unseen ways. Everything shifts, adapts, and flourishes quietly in the dark, just as your neural networks adjust beneath the surface of awareness. Even attention itself participates in this ongoing evolution. Where you direct your focus toward curiosity, reflection, learning, social interaction, or mindful awareness, you strengthen circuits aligned with that focus. Where you habitually ignore, avoid, or suppress, pathways may weaken. Attention is a sculptor's hand, subtle yet effective over time. By noticing this, you can gently guide the shape of your mind without force. You also carry the echoes of social interaction, memory, and emotion into this quiet space. Conversations, shared experiences, and emotional resonance leave patterns that continue to influence network strength and connectivity. Your social brain continues to integrate lessons from relationships and interactions, even while you rest. Empathy, understanding, and connection ripple through your networks silently, supporting adaptability and perspective. Breathing and bodily rhythm continue to communicate with the brain, modulating arousal, maintaining blood flow, supporting metabolic processes, and enhancing the efficiency of synaptic change. Motion and stillness remain intertwined as partners in neural health. Even minor postural adjustments, subtle inhalations, and exhalations carry information to the mind, maintaining the harmony of the system. Novelty and curiosity, when nurtured, continue to fuel the brain's capacity for growth. Small new experiences, tiny moments of attention, and micro-practices accumulate. Each gently sparks connections, opening doors in previously quiet regions of the mind. Learning, adaptation, and creativity persist across days, weeks, and years. The mind never fully stops evolving. You might notice that even your emotional states, contentment, reflection, calm anticipation, influence the patterns of change. Positive emotional tone encourages integration and strengthens circuits associated with resilience, curiosity, and flexible thinking. Negative or unprocessed emotion can temporarily tighten pathways, but the ongoing rhythm of sleep, reflection, and attentive practice gradually restores equilibrium. Change continues in subtle cycles, like water seeping through layers of rock, shaping contours with patient persistence. And now, as you prepare to drift fully into sleep, you might imagine the night gently tending your mind, neurons communicating softly, memories consolidating, networks recalibrating, pathways integrating. You can let yourself rest in trust, knowing the brain's quiet work continues, preparing you for tomorrow's small sparks of novelty, curiosity, attention, and social connection. And as your awareness fades into the gentle embrace of sleep, you carry one final thought, soft and comforting: flexibility never fully sleeps, and neither does the quiet potential for growth, waiting patiently beneath the surface of every moment, for you to awaken again and continue your journey.